Hello, everybody. Today I'm going to be talking about a technique to compromise federated identity and access management when MSSQL is used for ADFS configuration storage. Unfortunately, as you can probably hear, I'm a little bit under the weather. I nearly didn't turn up today, but thank the Lord for American over-the-counter medication. It's much stronger than the UK stuff. I can tell you that. Cool. Here's a little agenda for the presentation. I'm going to talk a little bit about myself, when this research happened, and why this research came to be. I'm going to be covering some of the relevant configuration options for Active Directory Federation services. I'm going to cover some of the very famous Active Directory Federation services attacks. I'm going to talk about one of the specific very cool pieces of tradecraft that came out of APT 29, specifically this magic web. And I'm going to be giving a demonstration of a technique that I've come up with myself called SilentWeb. So to give the who, the what, the when, the why of the project, the who, I'm a security consultant for WoodSecure Consulting. I primarily do things like network security research, macOS application 0 and end-day research. I have some certifications, not that they really matter. I've spoken at some conferences before, B-Sides, a couple of B-Sides, ZeefCon, Beacon, Balcon, etc. This is my personal blog and my handle, not that I really have an online presence. I've got some CVEs and things, mostly macOS stuff, because barely any people have looked at it, so finding 0 days in it is super easy. Some Hall of Fames, and I post some stuff on our research blog platform. And most importantly, I enjoy research and development. So, what is Active Directory Federation Services? At a high level, it enables federated identity and access management. Essentially, if you've ever logged into an app internally and you've been redirected to this thing to log into, it's most likely been ADFS. I am aware that I'm speaking at the SpectreOps conference, and a lot of people here are much smarter than I am and have a lot more knowledge about identity, but there might be some people watching that don't know what ADFS is. So I will still give a high-level overview of what it is. As I mentioned before, if you've ever seen this in enterprise, it's more than likely been ADFS. ADFS has been doing the heavy lifting when it comes to authenticating to an app via SSO. As you can see here, I've set up OWA with ADFS, so you get redirected to ADFS and then you get redirected back, and the magic happens in the background and you get access to OWA with federated authentication. A little bit of a high-level overview of this authentication flow. You want to log into OWA, you make a GET request there. Exchange will redirect you and say, hey, go to ADFS and get a token. You go to ADFS and you log in and you go, here are my credentials, and then you log in. ADFS makes a lookup to Active Directory if it's configured as the information store. The domain controller will tell the ADFS server that this user is legit. A token gets generated that's signed to prove that it's trusted, and then that gets given back to Exchange, and you get a login. As part of this process, the ADFS server has something called the claims pipeline. This pipeline represents the path that claims, like pieces of information that the user is claiming to have, goes through before it can actually be issued into a token. ADFS manages this entire process, and there are different pieces of information stored in different places, and there's different components involved in this issuance process. I'll cover this in more detail later on in this talk. When you configure ADFS, there are two main configurations. So typically, in smaller organizations, you use something called WID, which is the internal database, the Windows internal database, which is like MySQL Lite. It's much smaller. It usually resides on the actual ADFS server itself, compared to an SQL database in a standalone configuration or in a high availability configuration. That essentially allows larger organizations that with far more trust relationships to operate. You get things like Windows Server failover clustering. I'll talk about this a little bit later as well. Essentially allows more disaster recovery and availability. Cool. So in this specific lab environment that I set up just for this talk, essentially you have Exchange, which is the relying party, uses Active Directory Federation services as the security token service, gets information from the domain, which is the contoso.local domain, and then that information is provided by the domain controller. I've also set up a always-on availability group, so you have two SQL servers in a pair, so you get like failover clustering. So if one goes down, you have information on the other database server. Cool. And that leads us nicely onto the when and the what of this presentation. We did a project with one of our large banking clients, and essentially started with like a standard security build review of some of the ADFS components, so the Microsoft SQL Server and the actual ADFS servers themselves. Looking at the domain, it was very evident that they had treated the ADFS servers correctly as tier 0 assets, as documentation suggested. However, the MSSQL servers weren't treated appropriately, as I'm supposed to be clicking through here, as documented. But what actually about the what suggests that the MSSQL servers should be treated as tier 0 as well? There was surely more to demonstrate than what most people have demonstrated as carrying out golden SAML attacks. Here's a bit of information in the legacy Bloodhound view of the domain. It had roughly 20,000 users, 200,000 users, 50k groups, 35k computers. So it was like a small, medium-sized production domain. There were a lot of objects that had inbound transitive object control over the SQL servers. So a lot of paths that an attacker, if they were in the right positioning, could take over one of these configuration stores. And no, your eyes aren't going bad. This is blurred on purpose because it was leaking a lot of information. But there were a lot of principals that had control over these SQL servers, as you can see here. This was for SQL Server 1. This was SQL Server 2. There's a lot. Yeah, it's shocking. So you may be thinking that a lot of objects had inbound control over those SQL servers, and you're correct in thinking that. It was scary how much control was delegated. And this leads us nicely to the why. We had a number of attack paths where you could get a low-priv foothold through like a password guessing attack, and there were hundreds of database administrators. And we wanted to demonstrate to the client why there was a reason why they should essentially tier these SQL servers appropriately. While golden SAML attacks are impactful and they're pretty cool, like some nice tradecraft, there are some pretty high fidelity detection opportunities available for golden SAML attacks. And we wanted to do something to prove impact without carrying out token forgery. Before I continue with the talk, I'm going to talk about shared always-on availability groups, because they made use of this this configuration, and we were able to leverage it to achieve elevation of privilege on the database. In this case, yeah, cool. AOA groups essentially replace a single SQL node. So essentially you can have multiple databases that have the configuration replicated across them. They had a lot of unrelated Active Directory users granted logins to the database, and they had configured this AOA cluster to all run under the same MSSQL service account. So essentially so they had 4 MSSQL servers, 2 ADFS servers in this specific pool we were looking at, and every single MSSQL server was using the same group managed service account. And if they haven't configured extended protection, which they didn't, you can essentially do a cross-protocol relay if you can coerce authentication to go from SMB, get NTLM auth, essentially redirect it to MSSQL and get code execution as the MSSQL service account. Cool. So an always-on availability group is essentially when one or more user databases can fail over together. Essentially a primary availability replica can have 4 or more secondary replicas, and each replica is hosted on its own individual SQL server instance. Essentially, there'll be like a name, a DNS name, like an A record associated with the pool. And essentially, when you point your client to that A record, it will be smart enough to know, hey, go to this one's overloaded, or go to the third one, or go to the fourth one, etc. As I mentioned before, if you can find a way to coerce authentication, you can very likely get elevation of privileges or execution as the service account running the cluster, if they're all using the same service account. So in this case, I've replicated it in a lab, but they had disabled easy relay coercion primitives, such as XP Dirtree, XP file exist, etc. However, based on a piece of tradecraft that one of my colleagues developed, you can use an undocumented stored DMO called DMOS enumerate file system, which under the hood calls XP Dirtree, and essentially you can get authentication relay. So in this case, I've just used NTLM relay X to relay it back to a secondary in the pool of high availability servers and get code execution as the MSSQL service account. So that was an easy little technique that we used to gain elevation of privileges like a standard public user. Cool. So that leads us to like a literature review section. Essentially, before undertaking any like poking at software, as I like to put it, it's good to look at what other people have done, so you don't like repeat effort or you don't like encroach on what other people have done. So in this section, I'll cover some notable examples where people have categorized ADFS server components. This talk by Mandiant in 2019 was essentially the first conference talk I watched when I was researching ADFS. This was the talk where they released ADFS Dump and ADFS Spoof to the public, which are pretty impactful tools, and I'm sure a lot of people in this room have used these tools if you've done anything against ADFS. They're very useful tools. This talk, essentially, a lot of the weight was golden SAML attacks. So get access to the encrypted PFX or the token signing cert and essentially carry out golden SAML attacks. This talk as well, I'll go back, sorry, I saw someone was taking a photo. This blog post by Dr. Azure ID was a great source of ideas for this research project. Essentially covered multiple ways to export the configuration database, get the information stored there, which has the encrypted PFX, and it also covered a means of editing policy store rules on a Windows internals database for accessing the config remotely. And this gave me some ideas. So if you can modify these policy store rules, you can essentially allow certain principals to get access to things that they shouldn't have, which was very interesting. It also had some detection avenues, which was super useful for writing the detection side of this research project. This was the associated post for that blog post. Associated presentation for that blog post, again, was by Dr. Azure ID, and all of the routes led to golden SAML, which was annoying but good research. This talk as well at Troopers 24 by Sean Metcalf. I'm sure you've heard his name if you've done anything with Active Directory. This was one of the more notable presentations because they explicitly said treat the SQL server and database as tier 0 and in a top level OU, which is amazing to see. All of these posts and all of these presentations and posts had one thing in common. It all led to golden SAML attacks, so getting access to this token signing cert and forging tokens. I'm sure there was something more to do than that. So essentially with golden SAML, you get access to the token signing cert, decrypt it, and then you can forge information. However, golden SAML attacks are old news, and I'm going to show you why gaining access to an MSSQL configuration store in a post-compromise scenario is a bad thing. Cool. That leads us on to a section where I was looking at some of the APT29 tradecraft, where they carried out some very interesting attacks during the SolariGate compromise. However, in this section, all roads lead to golden SAML again. This specific compromise, the SolariGate compromise, was when SolarWinds was compromised, and essentially APT29 got access to the build pipeline for a piece of software called Orion. What they did is they essentially developed a piece of malware called Sunspot, and Sunspot essentially modified the Orion build process and essentially implanted arbitrary stuff into the resultant product that got signed and then distributed to clients. It was really, really interesting piece of tradecraft. So essentially September 2019, SolarWinds was breached. In October 2019, a version of the Orion platform was modified as a test. In February 2020, the actual Sunburst backdoor was baked into the Orion platform. It was signed, and then in March, it was distributed to environments via a software update. Hands-on keyboard activity started via Teardrop, which was a custom Cobalt Strike loader, and essentially allowed them to arbitrarily attack ADFS federated applications via golden SAML attacks. Another piece of malware that was discovered around the same time was FoggyWeb. Essentially, FoggyWeb was a piece of malware which was loaded via DLL search order hijack into the CLR. This essentially allowed them to gain access to interesting pieces of material associated with ADFS, so specifically the token signing certificate, the token decryption certificate, the actual ADFS configuration itself, and obviously like command and control functionality, so download, upload files, execute files, etc. So again, this exfiltration of the token signing certificate leads to golden SAML attacks, forgery of information. However, there is one problem that now people are aware of when it comes to golden SAML attacks is there's essentially a discrepancy in that authentication process. While golden SAML attacks are cool, they have this well-known discrepancy in this authentication process, which I'm going to cover. In this blog post by Sinjia, they talk about the legitimate SAML flow. Rather than recreating this, I just borrowed their image because it was a good overview. There's like a pretty standardized process, which I'll discuss slightly later. Essentially, this access request happens, the redirect, I covered it in that flowchart. However, in a forged token attack, it's missing this communication with the actual ADFS server and the domain controller. If you can correlate authentication events, you can pretty easily identify that this has happened, this has occurred. Microsoft Defender for Identity has this detection in place. Yep, cool. This leads us on to a piece of pretty cool tradecraft called MagicWeb, has inspired the name of the technique that I developed. This wasn't related to SolariGate or FoggyWeb, however, it was like discovered around the same time. This was a ADFS claim transform backdoor. I highly suggest reading this blog post if you want like nitty gritty details about it. However, at a very high level, another annoying thing was Microsoft didn't actually release any IOCs specific to the malware that was used in this intrusion chain. They didn't provide any hashes or samples, but they did provide some extremely low quality blurry screenshots of dnspy decompilation, which was fun to try and implement myself. What APT29 did was they backdoored this component called the diagnostics DLL, which is loaded at the start of ADFS's the service like spawn. It essentially provided debugging and tracing functionality to ADFS. So anything to do with like event logs or like logging, it was provided by this DLL. So if they backdoored this, it was always guaranteed to be loaded and had visibility of things that were loaded later on. Essentially, I implemented a version of this myself. It was super easy to do. You just load it in dnspy and just write your own code and click edit class, paste your code, and then etc. This was just a toy example. I plan to release this implementation at some point, but right now the code is really not clean, and I'm too busy to release it. So essentially, all they did was modified this DLL, signed it with a SNK, modified the global assembly cache, and then essentially modified the config, and then ADFS would happily load this DLL as instructed to by the public key token associated with the modified DLL that was signed. And this leads us nicely onto the technique that I've developed, SilentWeb. SilentWeb is essentially ADFS claims engine poisoning. This essentially allows you to subvert the claim generation pipeline through poisoning issuance transform rules. So if you can get into this issuance process, you can essentially denote what the resultant token contains. Before I get into the technique details, I'm going to talk about I'm going to compare and contrast the two techniques, the FoggyWeb and MagicWeb, versus the technique that I've developed. Both FoggyWeb and MagicWeb both require an administrative foothold on an ADFS server. This technique doesn't need an ADFS foothold. It only needs a foothold on an MSSQL server as DBA or equivalent, which, as I've discussed earlier, in the example environment that I was in, wasn't too difficult to achieve. Again, requires administrator access to ADFS. This just requires read-write access to the ADFS configuration V, and then depending on the version of ADFS you're dealing with, in my case V4. FoggyWeb requires a DLL search order hijack with an unsigned DLL. MagicWeb requires a modification of the GAC with an unsigned DLL. My technique doesn't require any unsigned compiled resources. those two techniques require you to restart ADFS. Mine just requires you to wait for the configuration to sync, which can be 300 seconds, 5 minutes, or you can actually modify it to be as quick as you want, but I'll talk about that. Both those techniques require you to touch disk, so drop a piece of code to the actual file system of the target ADFS server. My technique doesn't require that; it just needs a modification in the MSSQL database itself. However, pros and cons, those techniques are relatively flexible, so they can arbitrarily change users and target different users. My technique is pretty hard-coded and fixed and not very flexible. So again, back to this architecture diagram of the lab. If an adversary were to have a foothold on either the SQL01 server or SQL2 server, not an actual operating system foothold, but a foothold within the MSSQL service itself, so either via SSMS or an etc. other Microsoft SQL client, so MSSQL.py, etc. They have a way of essentially targeting what's holding the ADFS configuration. So when you're setting up OWA and ECP, you can develop this PowerShell code to set up issuance transform rules, authorization rules, etc. Essentially, OW and ACP use issuance transform rules in order to stamp the user's primary SID and user principal name into the token that gets signed and then passed to the relying party. So what actually are these? What are these issuance transform rules? The issuance transform rule consists of multiple components. So in this case, there's a condition block, issuance statement, attribute stored to query. So in this case, it's Active Directory, the actual AD authority. The type to accept, essentially this is the one for the primary SID, security identifier, has a type to query, the object SID, and then the type to accept, which is the parameter that's incoming, so it'll be associated with the user. Essentially just configures what information is sent to the relying party. In this case, it's just the primary SID, as I said before. Using the Claims X-Ray website, you can easily visualize this. Adam Chester's talk from last year essentially just gave me inspiration to use Claims X-Ray. It's a super useful web app. You can essentially set it up as the relying party trust, and then essentially, you can see the actual information in the SAML token really easily without having to base64 decode, etc. Cool. So in this case, when you log in legitimately, it just shows you the primary SID and the user UPN of the user. So in this case, it's just 1115 and then low priv. You can actually use this keyword called regex replace, which is conveniently available in the claims language, which is documented on Microsoft. But this essentially does what it says on the tin. It does regex replaces. So in this case, I'm just doing a regex replace of the target, which is the claim value, replacing the value of fed, which is the new domain I created, federated.local. So fed, low priv. If that information is passing through the claim, then passing through as a claim, then it gets hot swapped out as fed domain admin. So in this case, you can go to the IDP initiated sign-on page in ADFS. You can essentially log in as low priv, and then you get login as domain administrator. So I showed you an example where you needed a foothold on an ADFS server to run those PowerShell commands. However, you can do the same thing via the database. So this ADFS configuration v4 identity server policy.policies table contains these actual issuance transform rules. So if you have information about what's in this database, you can modify these cells, the information that's actually stored in the database. So in this case, I've just hot picked one example which was related to ECP and OWA. So I've inserted with the regex replace keyword, and then hot swapped out low priv for domain admin. Cool. I can give a demo where I've actually attacked OWA. Oh yeah, before I give the demo, one of my colleagues recommended I gave a high-level overview rather than just throw in a demo. So in this case, an attacker queries and modifies the issuance transform rules related to OWA and ECP. So they modify it with the regex replace keyword. They wait for a configuration sync. So in this case, 300 seconds, so 5 minutes. They attempt to log into OWA. they get redirected to ADFS. So they log in as lowpriv.contoso.local. ADFS does a user lookup for at contoso.local. The claims pipeline with the poison transform rules gets processed. The user gets given a token for the domain administrator user with the UPN and the SID, and then they log into OWA as the domain administrator. Cool. I have a live demo. Cool. So I log in as a lowpriv user. Yep. So orange is lowpriv. So I sign out. I just copy the URL for OWA. I make a query to the database for the issuance transform rules. So the standard rules, the default rules. I copy it. I paste it into Notepad. So you see here it's the default rules that are suggested when setting up OWA and ECP. Yep. Same default rules. Here I'm essentially just inserting these poison rules with the regex replace keyword. I've updated the rules. I make a query to the rules again. As you see here, the rules are now poisoned with this regex replace keyword. Same with ECP. And now I attempt to log in. I log in as an administrator for some weird reason in this demo, but I log in. It's the first time this user is logged in. Cool, administrator, I log out. I refresh. The configuration hasn't synced at this point, however, I speed up the recording. And now when I've logged in as lowpriv, my token's been hot swapped out to be domain administrator. Cool. Cool. So now the best offense is your defense, the best defense is your offense. So I'm going to talk about some of the detection and prevention avenues for this little technique. So this blog post by Dr. Azure AD has essentially covered some of the best detection avenues for adjacent techniques associated with the Windows internals database. I modified these and applied these to standalone MSSQL servers and specifically to the configuration store, like the policy store databases. So essentially you can just create audit on policies update. So in this case, I essentially just create an audit event for updates to the ADFS configuration v4 identity server policy.policies database table. So any users in the public role that makes updates to these will produce a event. This event 33205 contains information that's like super useful for detection. It includes things like the actual update statement that was performed, the connecting client application name. So in this case, MSSQL, which would be pretty unusual to see connecting to an ADFS configuration store and making update statements. It actually discloses the client host name. So I was connecting from a Linux machine just called with the hostname computer. It includes that information. Pretty useful. It includes the computer that was actually generating the event, the audit event. So as I said before, the application name and hostname attributes, it discloses the connecting application, the hostname. There's a weird discrepancy, which I'm pretty sure is like an intentional IOC with MSSQL client.py. The connecting client hostname is a pseudo-random, what was that, 1, 2, 3, 4, 5, 6, 8 character hostname. So that'd be a pretty interesting IOC to essentially develop, to use. It's probably useful for red teamers to know as well. If you're using MSSQL client.py offensively, it's good to change that in the source code. So you wouldn't have that IOC. So you just modify it to hard code as .NET SQL client data provider. Other things would be login events, the actual MSSQL configuration stores. They shouldn't happen very often and they should be like managed. Recommendations, monitor for changes to the ADFS configuration policies database. Use different managed service accounts for different roles in the ADFS farm. So don't use the same service account for ADFS and the MSSQL configuration database service, the MSSQL configuration store service, because it allows that relay to happen. If you can relay from one database server to another, then you can actually make modifications to the database. Configure extended protection to completely iron out that relay opportunity. treat ADFS servers as tier 0, and most importantly, treat MSSQL configuration stores as tier 0 as well. I hope that's enough evidence to essentially send that point home. Some useful references as well, some of the sources that I used when I was reading up about this, including all the presentations I referenced. Are there any questions?
Have you noticed the schema for that database changing between versions at all?
I haven't looked at anything earlier than ADFS 2019. Yeah.
But it has been consistent since then?
It's the same version. So I
Oh,
think the
okay.
latest ADFS is 2019.
Oh, okay, okay.
Yeah, even if
Nice.
it's like running on 2022, it's still 2019. Yeah.
Huh.
I haven't looked at anything earlier. Yeah.
Okay, okay, nice.
The scheme is a mess as well. If you've ever looked at the database diagram, it's horrible.
So I asked you when I came in whether this worked on AD Connect as well, and you said you didn't know. But I'm wondering, particularly the table that you're modifying is uh, 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 AD Connect or ADFS server policies.policies.
Yeah.
I'm wondering, anybody know if that table exists in the AD Connect server schema? I'm wondering if it does, because if it does, it's probably the same.
Possibly. I haven't ventured much into the cloud side of this. I was planning to, but I didn't get enough time to essentially do it. But yeah, in theory, you could be able to, if you had a hybrid deployment and you had an on-prem ADFS server that allowed access to cloud resources, then if you were to make modifications here, then they would allow you to go cloud-wide. Oh, I'm not entirely sure. Because in theory, golden SAML attacks do allow you to cross that cloud boundary as well. So in theory, this should still apply that way. But yeah, further research. I do also have one more thing. If anybody has a way to get actual samples of Magic Web, I would be highly appreciative of it. Obviously, Microsoft didn't produce samples. Anybody I've talked to required me to sign an NDA, and I'd like to do a piece about the actual samples themselves. So feel free to scan the QR code or send me an email if you want to donate a sample to me. Thank you. Cool.